Welcome to this class. Today I am continuing the chapter Pressure of the subject Science and Technology of class 10, and it is taken in the unit number 8. We have divided the chapter Pressure into 7 different parts, and this is the last part, 7th part of this chapter Pressure. Okay, today we are going to focus on flotation of the body. In which condition a body floats and in which condition it sinks. We'll focus especially on the condition for flotation of the body. Okay, let's start. Let's say this is water taken in a vessel, and if a solid body is placed in it, we may have 3 different conditions. The solid body may sink into the liquid like this. Sink means what? It goes up to the bottom of the container and it lands at the bottom of the container. Or it may remain as suspension inside the liquid. Suspension means it is lying somewhere inside the liquid, not landing at the bottom, not on the surface also, somewhere inside the liquid, maybe near to the surface or maybe near to the bottom, but it is suspended. This is second condition. Either it sink or it remain as suspension, or it may float in the liquid also. Look at this. These 3 are the conditions for the body. Yeah, when a solid body is placed in liquid, either it sink or it float or it remains as suspension. What is the science behind this? What is the reason? I want to describe reason with the help of density. If density of the body is greater than the density of the liquid, then it sinks into the liquid. If density of the body is more, it will sink into the liquid. But if the density of the body is equal to the density of the liquid, then it will remain as suspension inside the liquid like this. And if its density is less than the density of the liquid, then it floats. Can you give example of this? At least we can give example of the floating and sinking. If a piece of stone is taken or if a piece of iron is taken and it is placed in water, certainly it sinks in water, isn't it? But a wooden piece floats on water like this. And there are certain material which remains as suspension in the liquid. These are the reason behind flotation and sinking and suspension of the body in the liquid. Okay, now I want to tell you the same thing. If you are told that in which condition the body sink, then you can say that a body sink in a liquid if its density is greater than the liquid. Yes, and in which condition the body remains as suspension in the liquid. If you are asked this, then you can say that a body remains as a suspension in a liquid if its density is equal to the density of the liquid. But the flotation, in which condition a body floats? A body floats on the liquid if its density is less than the liquid. Okay? These are the possible cases when a solid body is placed in the liquid. In the context of the density of the liquid, I explained this. Now, let's have law of flotation. Today we are going to focus on law of flotation. There is a law for the flotation. According to the law of flotation, a floating body displaces the liquid equal to its own weight. Very interesting. Have you noticed this? What is told here? Floating body displaces the liquid equal to its own weight. What it means? If a piece of wood is floating in water, certainly wooden piece floats on water. If wooden piece is floating on water, at this time, it displaces the water equal to its own weight. If its weight is 1 Newton, during flotation, it displaces 1 Newton water. But if a big piece of the same wood is taken in water, it also floats. But at this time, if its weight is 20 Newton, then during flotation, it displaces 20 Newton of water. And you can imagine about this ship also. A ship floats on seawater, and during its flotation, if its weight is 10 crore Newton, then it displaces 10 crore Newton of water, then it floats. During flotation, every floating body displaces the liquid equal to its own weight according to law of flotation. Now I think law of flotation is understood, and this is the heart of law of flotation. We can say that weight of floating body is equal to weight of displaced liquid. Okay, this is very simple matter, and I think this matter is clear to you. Now, why don't we do this practically? I mean to say, there is experimental verification of law of flotation. When I taught you this Archimedes principle in previous class, at that time also, Archimedes principle was experimentally verified. In the same way, we can verify this. What? Weight of floating body is equal to weight of displaced liquid experimentally. Now, I am going to verify this experimentally. This is experimental verification of law of flotation. Let's have a top pan balance. This balance is called top pan balance because pan is at the top. And a Eureka can is taken on it, which is completely filled with water. This is Eureka can. It is completely filled with water. No more water can be added. If we try to add more water, then it will come out through the spout. It will go away from the spout. It is completely filled. Now look at the weight. Here it is shown by the pointer. Let's say at this time its weight is 10 Newton. The combined weight of Eureka can and water is 10 Newton. Okay, we have to take record. I mean to say, we are writing that combined weight of Eureka can and water is 10 Newton. We have to take this value. Now, we are continuing the same experiment, the same top pan balance and the same Eureka can, and it is filled up to the spout, but at this time, I want to take one piece of wood and I want to put it into the water. What happens? Look at the wooden piece. It floats, we know that, because its density is less than the density of water, that's why it floats. This is wooden piece. Very interesting, again combined weight is 10 Newton. Why? How it is possible? Combined weight is 10 Newton. Even after adding this piece of wood, we have combined weight 10 Newton. The reason is very simple. This wooden piece displaces certain amount of water. If we collect this water, then certainly the weight of this water displaced by this wooden piece is equal to its own weight. Since the wooden piece is displacing the water equal to its own weight, because of this reason, the combined weight is again found to be 10 Newton. This way we can conclude the experiment. This way we can conclude experimentally that according to law of flotation. This way I want to again tell you that according to law of flotation, a floating body displaces the liquid equal to its own weight, and heart of this law is weight of floating body is equal to weight of displaced liquid. This way we can verify this law of flotation experimentally. Now, after this, let's talk about the condition of flotation. In which condition a body floats on water or any liquid? Let's talk about this. The condition for flotation, the first condition is a body floats on the liquid if its density is less than the liquid. If a body has less density than liquid, it floats. Paper floats on liquid in water, and in the same way the wooden piece float on water, and the plastic also floats on water because their density is less than water. That's why they float on water. There is another condition also for the flotation. A body floats on a liquid if it displaces the liquid equal to its own weight. Very interesting. If a body has more density, even though it can float on the liquid, even after being denser than the liquid, it can float if it displaces the liquid equal to its own weight. Okay, I want to show this practically. Look at this. This is a small bowl and it is made up of steel, and density of steel is greater than water. Density of water is 1 gram per cubic centimeter, but density of steel is about 7.8 gram per cubic centimeter, even though it is floating in water. Because of this special cup-like shape, it is able to displace the water equal to its own weight, so it is floating. It can be understood this way also. Look at this again. Let's say this water taken in a vessel and a bowl is taken in it. I am showing this bowl very slowly. The reason is very simple. I want to show that what amount of water or liquid it displaces from this position. Again, look at this carefully. Lot of water is displaced, and because of this lot of displaced water, now it will be able to displace the water equal to its own weight. If it displaces this much amount of water, then the weight of displaced water will be equal to the weight of the bowl. And when these two weights are equal, then the body floats. That's why if a body has greater density, even though it floats in water, if it is able to displace the weight of liquid equal to its own weight because of its special cup-like shape. Okay. These are the conditions in which the body floats in the liquid. Okay, now I want to tell you about one interesting question. A man can think about this. An iron nail sink in water, but a huge ship made up of same iron floats on water. Why? It's a very interesting question, isn't it? An iron nail sink in water, but a huge ship which is made up of iron floats on water. What is the reason? Now I want to explain this a little clearly. When an iron nail is placed in water, it displaces the water whose weight is less than the weight of iron nail. The weight of displaced water will be less than the weight of iron nail. Weight of iron nail acts in the downward direction, and the off thrust, which is equal to weight of displaced water, acts in the upward direction. Since off thrust is less and weight is more, so an iron nail sinks in water. But the same iron is shaped like a cup in case of huge ship, and because of its special shape, now it is able to displace very huge amount of water, and it can displace the water equal to its own weight also. And according to principle of flotation, if a body displaces water equal to its own weight, then it floats on water. So a ship, huge ship made up of iron, also floats on water. It can be described very shortly like this. According to Archimedes' principle, off thrust is equal to weight of displaced liquid. Weight of iron nail is greater than the weight of water displaced by it. So weight of nail is greater than the off thrust, hence it sinks in water. But a ship is made in such a way that it has a lot of hollow space inside it, so it can displace enough water that is equal to its own weight. According to law of flotation, off thrust is equal to weight of displaced liquid, so off thrust becomes equal to weight of the ship, hence the ship floats on water. This way we can answer. Okay, now there is another question also, another statement also. This is common statement that only the objects having density less than water float. Is this correct? Is this statement correct? If you are told that only the objects having less density floats on water, is this statement correct? No. I described about this in previous slide also. This is not correct statement if an object is able to displace the liquid equal to its own weight because of its special shape, then also the body floats on the water. That's why we can say like this. This statement is not true. A body having less density than water floats on water, but a body having density more than water can also be made to float on water if it is made hollow inside. Then it becomes able to displace the water equal to its own weight. According to law of flotation, when a body displaces the liquid equal to its own weight, then it floats on the liquid. So, a body having density more than water can also be made to float on water. We have to be clear about this. This is one of the important facts that sometimes you can be asked about this. A body having greater density floats on water. And you can say that yes, because of the hollow space inside it. Okay. Now I want to talk about the balloon. If a balloon is filled with air, it goes down. It won't fly up. But the same balloon is if filled with hydrogen gas or another gas like helium gas, which is very light. Hydrogen and helium gases are light gas. If a balloon is filled with hydrogen or helium, then it won't fall down. It will go up. What is the reason behind this? Now I want to explain this with the help of this diagram. Look at this is a balloon. Let's say it is filled with air. And if it is filled with air, then its total weight will be the weight of air plus weight of the balloon. Balloon is made up of what? Rubber. That's why rubber of the balloon plus the air contained inside it is the total weight of the balloon at this time. And weight x in the downward direction, its direction is towards the center of the earth. But what about the upthrust? When a balloon is placed in air, suddenly air exerts an upward force on the balloon that is called upthrust. And the value of upthrust depends upon what? Weight of the displaced air by this balloon. Which one is more? Upward force is more or downward force is more? Weight of the displaced air is more or weight of air plus weight of the balloon is more? Certainly the first part is more. I mean to say air with weight of balloon is more than the weight of displaced air. If it is so, then certainly it goes down. The balloon falls downward this way. If balloon is filled with air, it falls down because upthrust is less and weight of the balloon is more. But the same balloon is if filled with hydrogen gas, then what happens? The combined weight of hydrogen and weight of the balloon is the total weight of this balloon filled with hydrogen gas. And this weight is directed towards the center of the earth. But what about the upthrust? Upthrust is equal to weight of displaced air. And which one is greater? Weight of displaced air is greater or combined weight of hydrogen and the weight of balloon is greater? Certainly, weight of displaced is greater than the combined weight of hydrogen and weight of the balloon. Upward force is more, downward force is less. That's why resultant force x in the vertically upward direction. Because of this resultant upward force, the balloon moves upward this way. So, we can conclude that if a balloon is filled with hydrogen gas, then it moves upward. If it is filled with air, it moves downward. If we have to describe this shortly, then we can describe this way. Weight of air-filled balloon will be more than the air displaced by it. But the weight of hydrogen-filled balloon will be less than the air displaced by the balloon. So according to Archimedes' principle, of thrust is equal to weight of displaced fluid. I am talking about fluid now, not about the liquid, because this Archimedes' principle acts in both the liquid and in gas. So according to Archimedes' principle, of thrust is equal to weight of displaced fluid. So the off thrust on the air-filled balloon is less than its weight, so it falls down. But off thrust on hydrogen-filled balloon is more than the weight of the balloon, so hydrogen-filled balloon rises up. Okay, this way we can write certainly. After all this, I told you about the law of flotation and experimental verification. How can we verify the law of flotation, etc., etc. Now, it's time to talk about the question. Whether the subject matter is understood or not can be verified with the help of question. I want to put on this question. Look at the question. Three different bodies, they are named as X, Y and Z, have equal volume, and are lying differently in water. This liquid is water and their position in the liquid is different. One is completely immersed, one is immersed a little more, one is immersed a little less. Now question is, compare the density of Y and Z. Y is here, Z is here. Now we are going to compare the density of Y and Z. Z is suspended but Y is floating. According to the previous information, what I told previously, this density of Y is less than density of liquid. If a body is floating, it means its density is less than the density of the liquid. We can say this, isn't it? In the same way, Z is suspended. That's why we can say that density of Z is equal to density of liquid. Now looking at these two, dy is less than density of liquid and dz is equal to density of liquid. It means density of Z must be greater than density of Y. So we can conclude that density of the body Z is greater than density of the body Y. This way we can answer this question. Now let's have another question. What will be the weight of Y in its position? This is a little tricky question. Y is floating. At the time of flotation, what will be its weight? The question is, at the time of flotation, what will be its weight? According to law of flotation, just now I told you, weight of Y is equal to weight of displaced liquid. We know about this. Weight of Y is equal to weight of displaced liquid according to principle of flotation. In the same way, of thrust is equal to weight of displaced liquid according to Archimedes' principle. Archimedes' principle is applicable for all the bodies whether it is floating or sinking. The principle of flotation or law of flotation says that weight of this floating body is equal to weight of displaced liquid, but Archimedes' principle says that weight of thrust is equal to weight of displaced liquid. In right hand side, in both the cases we have weight of displaced liquid. That's why we can say that of thrust is equal to weight of Y. Isn't it? Of thrust means what? The upward force exerted by this liquid on the body. This is of thrust. And what is weight of the Y? Weight of the body Y means the downward force exerted by this Y because of its weight. Now these two forces are acting against each other and they are equal and opposite. So resultant force will be 0. That's why weight of Y in its position is 0. Weight of every floating body becomes 0. But don't be confused. If it is so, then why don't we push a big ship in the sea if its weight is 0? There is inertia. The inertia, we have to remember inertia also. A ship is floating, it means its weight is 0. Upward force and downward force both are equal, acting in opposite direction. That's why weight is 0. But huge mass of ship has got huge inertia of rest. and against that huge inertia of rest, we have to apply huge amount of force to move it, and we cannot, and certain engine is required to move a ship on the sea, in the water of sea. This way we can conclude that Y has zero weight. Okay, let's remove this now. Now let's have third question. Compare the upthrust on X, Y and Z. We are going to compare the upthrust on X, Y and Z. What do you think? Y, all of them have same volume, it is given in the question. All of them have same volume. But Y is emerging a little only. So weight of displaced liquid is less. And we know that weight of displaced liquid is equal to upthrust. Upthrust experienced by Y is less. But X is immersed a little more. It means it displaces the liquid more than Y. So weight of displaced liquid is more in case of X in comparison with Y. So the upthrust acting on X is more than Y. But what about Z? Z is completely immersed. All of them have same volume and Z is completely immersed. It means the weight of displaced water by Z is greater than X and Y. So the upthrust acting on Z is more than Y and X. So we can conclude that upthrust on Z is maximum and upthrust on X is less than Z and upthrust on Y is more or less than X. This way we can answer the question. Okay, let's have another situation, another question. Do you know that a ship is, if loaded with cargo, then it immerses more in water. But if a ship is not loaded with cargo, it is empty, then it will immerse less in water. What is the reason? I want to describe with the help of this diagram. Look at this, the level of water, and this is a ship, let's say, loaded with cargo. Cargo is normally placed at the bottom side of the ship. Cargo means the material carried by the passenger, and cargo is placed at the bottom, and this ship is immersing a lot. Why it is immersing a lot? According to law of flotation, every floating body displaces the liquid equal to its own weight. Its weight is more, that's why it has to immerse more to displace liquid equal to its own weight. But look at this another one. This ship is not loaded with cargo. That's why its weight is less. Because of less weight, it will immerse less. And when it immerses less, even though it is able to displace water equal to its own weight, that's why a loaded ship immerses more, but an empty ship immerses less. In both the cases, weight of displaced water is equal to weight of the ship. But in first case, weight of ship is very huge because of the cargo, and so it immerses more. In second case, it immerses less because weight is less. Okay, this way we can explain this. Shortly, we can say that a ship loaded with cargo is heavier than the empty ship. According to law of flotation, weight of floating body is equal to weight of displaced liquid. Since ship is heavier, so it displaces more water equal to its own weight. Hence, a ship loaded with cargo immerses more in water. Why don't we see this practically? Okay, look at this bowl. It is empty. And if I add some water in it, look at this, if water is added in it, now it is immersing more and more and more and more. Look at this. Why it is immersing more? The reason is very simple. During flotation, every floating body displaces the liquid equal to its own weight. Previously, its weight was less. That's why it was immersing less to displace water equal to its own less weight. But when water is added, now it becomes heavier than the previous and it immerses more in water to displace the water equal to its own weight. Now, let's have one question. what is the difference between Archimedes principle and law of flotation? It's very interesting. What is the difference between these two? They are not acting against each other. Actually, Archimedes principle is applicable for the body, floating body also, or the body is sinking. At that time also, Archimedes principle is acting, and if the body is suspended, at that time also Archimedes principle works. Archimedes principle works on floating body, sinking body, and the body in the suspension state also. But law of flotation is only for the floating body. According to Archimedes' principle, of thrust is equal to weight of displaced liquid. But according to law of flotation, weight of floating body is equal to weight of displaced liquid. Yes, this is the basic difference between Archimedes' principle and law of flotation. I think now you are clear about the law of flotation and the reason of flotation. Now we'll meet in another class with some another matter. I want to stop now. Thank you.